Hi, today I'm going to be going over vector projections. So, what's a vector projection? Well, projection is just mapping this vector v onto w. So we're mapping v onto w to get this new vector v prime. Now, there are a few terms that you should know. One of them is linearly dependent. So in 2D vectors, this is basically just saying that in this case, v prime is collinear to w. By the way, I can't spell. V prime is collinear to w. If you multiply w by some scalar, by some number, you can dilate it or shrink it to get some other vector v prime. And this means v prime is linearly dependent to w. Dependent to w. Now what about linearly independent? This is basically saying that v, in this case, is not collinear to w. So v is linearly independent to w. Now let's just make this a bit simpler. Linearly dependent is basically if two vectors are going in the same direction, they're linearly dependent. If you can multiply one of the vectors by a number, you can get the other vector. Linearly independent is they're not going in the same direction, right? So v over here and w over here, they're not going in the same direction, so they're linearly independent. If you multiply v by a number, you cannot get w. But if you multiply w by a number, you can get v prime. So keep in mind, when you're doing projections, v prime will always be linearly dependent to w. Now, how do we do projections? Well, there's a nifty formula for this. The projection, proj, of v onto w can be written as the dot product of v and w over the magnitude of w squared times the vector w. Now, if you do not know what any of these things are, dot product or like magnitude, multiplying vectors, then you should watch my first video, Fundamentals of Vectors. So let's just make sure that we're getting a vector here. We have the dot product of v and w. This is a scalar, a number. And here we have the magnitude of w squared, which is another scalar, meaning this whole number here is a scalar. This ratio is a scalar. Times a vector. And we know that a vector times a scalar is equal to another vector. And in this case, it's going to be v prime. All right, so this problem is asking us to project vector v, which is 2, 1, onto vector w, which is -3, 4. So we can use our projection formula. Projection of v onto w is just dot product of v and w over the magnitude of w squared times the vector w. And we can now plug in our vectors. So here we have vector v, which is 2, 1, times vector w, -3, 4, over magnitude of w squared. So magnitude of w is just -3 squared. I can just write this down here. Magnitude of w squared is the square root of -3 squared plus 4 squared, all squared. So this is just -3 squared plus 4 squared, which is equal to 25. So here we have 25 times our vector w, which is -3, 4. We can simplify this, or I guess do all the computations. Dot product of 2, 1 and -3, 4 is -6 plus 4 over 25 times negative 3, 4. This is just negative 2 over 25 times negative 3, 4, which is 6 over 25 and then negative 8 over 25. Know that the ratio between this resultant vector v prime and w, which is negative 3, 4, should be the same. So I'll just write w over here. W is negative 3, 4, meaning the ratio of the components is just negative 3 fourths. And then let's check that over here. Is that true? It'd just be 6 over 25 all over negative 8 over 25 is just 6 over negative 8, which is indeed negative 3 fourths. So our vector is this. And it should be pretty obvious that the ratio between the components is the same, because here's our vector w. We're just multiplying this by a number. So our ratios still stay the same. All right, so our new problem is asking for projecting the vector v, 5, 1, onto the vector w, negative 8, negative 6. So our projection formula is projection of v onto w, use the dot product of v and w, over magnitude of w squared times w. This gives us, I'm just plugging in our numbers, 5, 1 times negative 8, negative 6 over magnitude of w, I can write that here, squared is, first we'll just do this, is equal to negative 8 squared, I could just say 8 squared, plus 6 squared, all squared is just 8 squared plus 6 squared, which is 64 plus 36, which is 100. You could have also noticed that this is a Pythagorean triple, 8, 6, 10, which is just 3, 4, 5 scaled. But yeah, so that means our denominator is 100, and we have our w, negative 6, or negative 8, negative 6. Doing the dot product, we have negative 40 minus 6 over 100 times negative 8, negative 6 is equal to negative 46 over 100 times negative 8, negative 6. We can simplify this to be negative 23 over 50. Still negative 8, negative 6. And this is going to be equal to 23 times 8 is 160 plus 24. So 184 over 50. And then negative 23 times 6 is 120 plus 18, which is 138 over 50. And then we can divide all this by 2. We have 92 over 25 and 69, I believe, over 25. And this is going to be our final vector.